To test the table entries, patterns will have to be sent through the system to examine the responses. The source of these patterns will be called the dream machine. With memory to allow the data to be stored and checked after the patterns are run, the tests allow the changes to be examined before they are committed to the table. One simple test the system can use would examine positive, negative, or null outcomes. If the outcome of a test is positive when the expected result is negative, the confidence level will drop. I guess this is why the psychiatrists suggest you find your happy place when trying to overcome phobias. It will change the association. A large number of these tests would be run during sleep to ensure the table remains operable. By paralyzing the muscles, the body will not respond to the pattern sent through. If the paralysis fails, the individual may begin sleepwalking. At the beginning of my model's life, it will be incredibly adaptable. Over time, the need to reduce the response time will link pattern series across the tables. Steadily, the model will become set in its ways, and is therefore a good model of human behavior. But my model has a huge problem. The model will respond immediately to the latest input pattern, which can lead to disaster. Imagine a wildebeest running from a lion on the open plains. Since it cannot see the lion behind it, it will stop for lunch if it is hungry and sees a plant. This allows the lion to catch up and kill the wildebeest. To fix the problem, my model needs a method of holding a state. How would these state variables work? In the brain, these variables would be some form of natural capacitor. In my model, I'll use compressed air tanks with a hole in one side. The tanks will be fed from a high-pressure reservoir, and they will exhaust through a hole into a low-pressure reservoir. A pump will suck air from the low-pressure reservoir and push it into the high-pressure reservoir. To operate, the pressure in each state tank will be sent to the pattern generator for processing. In the case of the wildebeest running from the lion, it will run for as long as there is pressure in the tank assigned to that task. This configuration will have some plumbing problems. I cannot put a valve on the exhaust side, since this will prevent the state from changing. But the moment one of the state tanks is used, it will cause the pressure in the low-pressure reservoir to rise. With no valve on the exhaust side, air will automatically start entering the other state tanks. The brain will misinterpret this as an increase in that state. To prevent this, all of the meters will have to be linked with the pressure in the low-pressure reservoir such that the minimum value is always equal to the reservoir pressure. If the pressure is 0, the minimum value for each state tank will be 0. If the pressure is 1, then the minimum value will be equal to 1. A similar effect will happen on the high pressure side. When any state tank is used, opening the valve will cause air to enter the tank and lower the pressure in the reservoir. If the maximum was 10 and it dropped to 9 when a valve was opened, then the system would misinterpret this as a decrease in the state when it should be reading the maximum value. Therefore, the meters on each state tank must be tied to the pressure in the high pressure reservoir such that the maximum value is always equal to the reservoir pressure. As more state tanks are used, the pressure in the high pressure reservoir will continue to drop, while the low pressure tank readings will continue to rise. When the high value is 10 and the low value is 0, the system will have to move 10 units of pressure to get from the lowest to the highest state. If the high and low values are 6 and 4 respectively, then only 2 units of pressure are required to move from the lowest to the highest. In this case, the state will become hypersensitive. When the pressure in both reservoirs is equal, then the state will go from its minimum to its maximum value instantaneously. The state will seem to explode in the mind of the individual experiencing it. Of course, all of this can be corrected by using a larger pump, but that is not always advantageous. In the pattern response table, the system will always respond to a given situation with a predictable response. However, that response may not always be the correct one. For example, the vision of some predators is based on movement. If a prey animal senses the predator, freezing will prevent the predator from seeing it. If the predator can already smell the prey, it will move over to the animal that is waiting patiently to die. Using the pressure changes between these tanks will give the prey an opportunity to escape. Initially, when the predator is encountered, the prey will open the valve on a state tank, causing its muscles to freeze. When the pressure difference drops to a certain value, the prey will try plan B. It will run away. Thus, this configuration allows two strategies when dealing with predators. The ratio of maximum pressure difference divided by the current pressure difference will be presented in this display here. When operating at the maximum value, the ratio will be equal to 1. As the pressure differences drop, the ratio will increase. This pressure difference will be called stress. In turn, the stress value will be called the weighting, which is used by the system when computing the confidence levels. Under high stress levels, the system will adapt faster. To an engineer, these pressure tanks will hold the state variables which, in the words of a broken heart, are just emotions. And with that, I've found what I have set out to accomplish. I know what emotions are. I have identified some, but not all of the mental afflictions. Along the way, I've identified that mammalian intelligence was intended as a crippler to handicap the species. Adding intelligence by expanding the pattern response table will be beneficial. Expanding the use of the dream machine such that it is used during waking hours will not be beneficial. It will only serve to increase the flow of patterns through the system, slowing it down and using more emotions. Using more emotions will, in turn, increase the stress. In essence, it will become an amplifier of stress. This amplification leads to anxiety and mood disorders, as the high weighting values causes the system to create unusual condition threads on the tables. If a dog would bark, the condition thread may send the response of a human talking. When enough of these condition threads are formed, the brain would become completely unusable. The person would be insane. Now, intelligence will help to adapt to new threats later in life, but hey, wait a minute. My model has a fundamental logic error. And it is a nasty one.